So guys, in this video we will discuss about that the solution of system of linear equations by Gauss elimination method. So let us see that how can we solve a system of linear equation by using the Gauss elimination method. So first of all we have to know that what is the that how can we solve the Gauss a system of linear equation by the Gauss elimination method. And here I am going to discuss the theory portion of Gauss elimination method. So let's see that suppose if we consider a system of linear equation like in this form, that a11 x1 plus a12 x2 plus a1n xn is equal to b1, a21 x1 plus a22 x2 plus a2n xn is equal to b2, and an1 x1 plus an2 x2 plus dot dot plus ann xn is equal to bn. So here you can see that from here you can say here n variables and n linear equations. N linear equations. So here the coefficients, and here all the coefficients like aij, where I and I comma j is equal to 1 2 3 dot dot n, and the constants bi I is equal to 1 2 dot dot n, all are known to us. All are known to us. So now we can write it in the matrix form, that is ax is equal to b. So what is a here? That is a is equal to, this will give n cross n matrix a11 a12 dot dot a1n a21 a22 dot dot a2n and an1, the last row of the matrix. So here a is a n cross n square matrix, and here capital X is equal to, you can write x1 x2 dot dot xn, and b is equal to b1 b2 dot dot bn. So in the next portion, then now the question is that we construct the matrix form, and now how can we solve it? So here, that if we follow this one, so now here I'm going to telling you how the procedure of solving a system of linear equation by Gauss elimination method. So actually the Gauss elimination method is a direct method. This is a direct method. So now how can we solve it? Or what are the steps? So here the steps are, I'm going to write here. The steps are, that is x1 is eliminated from each equation except first row, or first equation except first equation. x2 is eliminated from each equation except first and second equation, and x3 is eliminated from first second and third equations. And this process is executed in a systematic manner. And so first of all, here we have to construct a matrix. So here I'm just going to introduce a new term, that is the augmented matrix. So what is the augmented matrix? The augmented matrix is the matrix where in the matrix B matrix is appended with the matrix A. So how it looks like now? So the augmented matrix is of the form. So now here I'm just for writing the expression of augmented matrix. I'm going to the new slide. That is, this will now look like A, B, and now this will be a n cross n plus 1 matrix, and this will look like A11, A12, A13 dot dot A1n, A21, A22, A2n, and here B1, B2 dot dot Bn. So now see that this is known as the augmented matrix. This is known as augmented matrix. And here, so now that how can I solve now? So here now in the first step, what will we do? That is, we are going to make this is equal to 0, this is equal to 0, and all the term in the first column except A11, we will make it 0 with the help of first row, and while we assume that A11 is not equal to 0. And see that if we make it 0, if we make it 0, and then what we get, that is we will get by like this, that is the elements of first row are unchanged, this is 0, this is a new term, so this will be, I just denote it by A221, next one is A231 and A2n1, and all will be same here, it will be changed. B21, Bn1. And now what would happen in the second step? In the second step, we will make this one, we will make all the elements here, that we will take this one is not equal to 0. That is A221 is not equal to 0. And in that case, and then we will make all the terms will 0 under elements under the A221. Okay, so now here, what we get? The matrix A11, the first row is remain unchanged, second row is also remain unchanged, and from the third row every elements will be changed, so we can write it A3 and 2, and if we go, this is 0, this is 0, A n3 2, A nn 3, and this will be B1, B2 1, and next one B3 2, and this will be Bn 2. Okay, and now similarly if we proceed this one, these conditions, then what we get? Then we will get at the, if we continue the process, that we will get that all elements, if we continue the process, and all elements below the leading diagonal elements diagonal elements of A are are made zero, so what we get? That is, we get, this is a n cross n plus 1 matrix. We get A11, A12, B1. This is 0, B21, 0, 0, A332, and so then this will be, that is A nn n minus 1, Bn n minus 1. Okay, and now see here these elements here, like the A11, A221, A332, An minus 1, these all are known as the pivotal elements. These all are known as the pivotal elements, and you have to remind one thing, that in the elimination process, if any of the leading diagonal vanishes, then we have to must rearrange the rows so to obtain a non-vanishing pivot, and this strategy is known as the pivoting. This strategy is known as the pivoting. And so now the question is that, now how can we find the unknowns like x1, x2, dotted xn? So we will here give the back substitution. That means now if you follow it, so next what we get? Actually here we get the equation, the system of equation like this: a11 x1 plus a12 x2 plus dot a1 and xn is equal to b1. Next we get a221 x2 plus dot plus a2n xn is equal to b2, and at last we get that ann n minus 1 xn bn n minus 1. So now from here, if we use the back substitution, so we can find all the values from here. That is, from here we get the value of x1, and then we will get the value from the xn minus 1, and also we will get all the values of xi when I is equal to 1, when I is equal to n minus 1, n minus 2, and that 1. So now here I'm just going to solve one problem here, that, and then it will be too much clear to you that how can you solve one system of linear equation by using Gauss elimination method. So now here I'm just going to show you. See here, write the first question, that solve the system of linear equation. Solve the system of linear equation by Gauss elimination method. By Gauss elimination method. 5x1 minus x2 is equal to 9 minus x1 plus 5x2 minus x3 is equal to 4 and minus x2 plus 5x3 is equal to minus 6. Okay, so now we have to solve this system of linear equation by Gauss elimination method. See here that how can we solve it. So this is the given equation. Okay, so now we can write the given system is equivalent to I can write it this equation by like this. So now we can write the given system is equivalent to the given system is equivalent to, or here I'm just going to the new slide. The given system is equivalent to, this is the augmented matrix. I'm just writing here the augmented matrix here, that is 5 minus 1 0 minus 1 5 minus 1 0 minus 1 5 and this one is 9 4 minus. This is the augmented matrix. This is the augmented matrix and the system is equivalent to, and the system is equivalent to 5 minus 1 0 minus 1 5 minus 1 0 minus 1 5 x1 x2 x3 is equal to 9 4 minus 6. Okay, so now here we have to use the elementary row operation. So here what is our first work? That is our first work is we have to make this one 0 and this one 0. See here that this is already 0, so we have to make only this element minus 1. We have to convert minus 1 to 0 by using the first row. So here we can give it here the row operation r2 dash is equal to r2 plus 1 by 5 r1. So from here what we get? 5 minus 1 0. This is 9. This will be 0. This will be, if we calculate, we will get this is 24 by 5 and this is remains same and this will be 29 by 5. This is now 0. This is minus 1. This is 5. This is minus 6. Now our objective is that we have to make this element 0 with the help of second row. So now what will be the element? That is R3 dash is equal to, we will give R3 plus 5 by 24 R. So from here what we get? 5 minus 1 0 0 24 by 5 minus 1 0 0 and this will be that if we simplify it we will get from here that this is 115 by 24 and this is 9 29 by 5 and this will be also, if we calculate it we will get that this is also minus 115 by 24. So now if you see if you just compare it this one with the with this augmented matrix, then now we have to give only the back substitution. So see here that from here can I write that 115 by 24x3 is equal to minus 115 by 24. So from here we get x3 is equal to minus 1, and also that from the second you will get 24 by 5 x2 minus x3 is equal to 29 by 5. And if we put the value of x3 here, what do we get? That is plus 1. So that means we will get also 1 minus 1 plus 29 by 5. So this will be 24 by 5. So you will get x2 is equal to 1. And if we use here, that is the 5 x1 minus x2 is equal to 9. And if we put the value of x2, so 5x1 is equal to 10. This will give x1 is equal to 2. So now from here we can say that this is the value 2, 1 and minus 1. These are the solution of the system of linear equation where, so now here we can write that 2 1 2 1 minus 1 is the solution of the given system of linear equation. And always remind you one thing, that the Gauss elimination method, by Gauss elimination method we can find the system of we can find the solution of the system of linear equation where the coefficient matrix A is always non-singular. So here I am just showing you one thing, that if you construct here the matrix, that is 5 minus 1 0 minus 1 5 minus 1 and 0 minus 1 5, you just see here that if you find right A, then you can check that data is not equal to 0. That means A is always singular, non-singular, and non-singular coefficient matrix, non-singular coefficient matrix always gives the unique solution. So whenever you solve any system of linear equation by Gauss elimination method, you have to remember one thing, that this will give you a unique solution. So I hope you understand the concept of Gauss elimination method. So thank you for watching the video.